So let's go ahead and do some computing of z-scores here. So we're going to suppose that we've got a random variable x that is normally distributed. And let's say that our population mean is 8 and our standard deviation sigma is 3. We want to compute the z-score for x equals 6 and explain what it means. So our z-score formula, remember, is x minus mu divided by sigma. So our x value here is 6 minus our mean is 8, and then we are dividing by sigma is 3. So this would be negative 2/3, which as a decimal is about negative 0.67. And the negatives indicating that we're below the mean and we're 67 hundredths of a unit below the mean. So if you look on the bell-shaped curve here, for the standard normal distribution, you've got z equals 0 in the middle, 1, 2, 3 on the right, and 1, 2, 3 on the left, negative. So negative z-scores, positive z-scores, z equals 0 is the mean. So the z-score for x equals 6 is at negative 0.67. So negative 0.67 would be about right here. So that is our negative 0.67. So these are z-scores. And then the corresponding x's that go with those. Well, your mean is 8 and your standard deviation is 3. So in the middle at 0 is going to be 8. And then your 1, 2, 3 standard deviations above, you would add 3 times. So 8 plus 3, 11, plus 3, 14, plus 3, 17, and then subtract 3 times. So 8 minus 3 is 5. 5 minus 3, 2. 2 minus 3, negative 1. So these are the x values that go with the whole number z-scores. And then z is negative 0.67. That went with x equals 6 right there, which corresponds to that point along our x-axis. So this is negative 0.67 standard deviations below the mean. So our x-axis is a ruler, and it's measured not in inches, but in standard deviations. So this distance here, again, is sigma, which for this distribution is 3. Z-score for x equal 13. So your z again, x minus mean over standard deviation. So that's going to be 13 minus 8 is our mean, divide by 3 standard deviation. So 13 minus 8 is 5, divide by 3, so 5/3, that's 1 2/3, so about 1.67, and that is positive, so that means 1.67 standard deviation units above the mean. So that means 1.67 for z-score is about right there. So that's 1.67. And then the corresponding x value is 13. So your 13 is between 11 and 14 here, and it corresponds to that 1.67. So the value 13 is 1.67 standard deviations above the mean. The value 6 is 0.67 standard deviations below the mean.